Hi and welcome back to another new video of Basics of Electrical and Electronics Engineering, which is a subject for first year K2 syllabus students. In today's video we are going to continue module 3 AC circuits. In today's video we are going to discuss which are the different forms of representation of phasor for mathematical calculations. We have trigonometric form, rectangular form, polar form and exponential form for mathematically representing a phasor diagram. So we are going to into the detail of each of them. So in the previous class we have studied what is phasor diagram. Next we are going to study how we can represent the phasor diagram using mathematical models or mathematical forms, how we can represent. Okay, so which are the different forms of representation? You can write phase representation of phasors, or you can say mathematical representation of phasors. You can write it as mathematical representation of phasors. Phasors can be represented as first one rectangular form, second one trigonometric form, third one exponential form, and the last one is polar form. Okay, we can for time being we can just convert. Okay, so first one and fourth one are the important one. The other two, trigonometric form and exponential form, we will be just going through. Let's move on to the first one, that is rectangular form. Okay, how can we in the rectangular form, how we can represent a phasor, that is we are going to study. So rectangular form. Any vector, we have studied that any vector can be resolved into two components, that is x component and y component. And using the concept of this resolving, we are using the representation known as rectangular form for phasor representation. So I'll just show you a phasor which is represented on the first quadrant. That means the phasor is this one, which is rotated by an angle theta. Now we can resolve this phasor into two quantities, two x component and y component. This is the x component value and this one is the y component value. Then we can represent the phasor as V is equal to x plus yj, okay, or jy. In representations we can use as jy, but when you are using in calculator you have to use as v plus yj. So I am writing here as x plus jy, okay, where the magnitude of this phasor is obtained by root of x square plus y square, okay, and the angle theta by which it is rotated from the zero axis is obtained by using the expression tan inverse of y by x. You have studied these in your +2 classes. I'll show you one more phasor which is actually in the fourth quadrant. That means a phasor which is used for representing lagging quantity from the reference axis by an angle theta. Again we can divide it into or resolve it into two components. One is the x component and here is the y component. Now this phasor V can be represented as x minus jy. Can represent it as x minus jy, and this voltage magnitude can be represented as root of x square plus y square, And theta can be represented as tan inverse of minus y by x. Okay. So generally we can represent the rectangular form. How we can represent? Generally we can say as v is equal to x plus or minus jy plus comes when the phasor is in the upper quadrant or in the first quadrant, and minus comes when it is in the downward direction, or we can say in the fourth quadrant. That means in lagging conditions we will use minus, and in leading conditions we will use the positive sign. And tan angle theta can be written as tan inverse of plus or minus y by x according to the phasor which is above the reference axis or below the reference axis. So second form is trigonometric form. So we are going to represent what is trigonometric form of representation. Okay, how can we represent in a trigonometric form? So again I am taking the phasor which is like this, angle theta, and we know that how we can resolve this into two components, that is x component and y component. And when we are resolving a phasor or a phasor v, we can write the x component as v cos theta. The magnitude is this one, and the magnitude, if you know the magnitude, you can resolve it into the y component as v sin theta. Now using these components we can just write like this. That means the rectangular form as v is equal to x component, that is v cos theta, plus y component, j into y component, that is v sin theta. Or we can also write it as, v can be taken outside, so you can also write it as cos theta plus j sin theta. Okay, this is the case when the phasor is to the upside, or you can say it is above the reference axis. When it is below the reference axis like this with angle theta, then the x component becomes v cos theta and the y component becomes v sin theta. Then you can represent the phasor as v is equal to v cos theta minus jv sin theta, or we can take the magnitude outside and the remaining things can be written as v cos theta minus j sin theta. Now how can we generally represent this one? As we just represented the rectangular form generally, we can write this one also in a general form as v is equal to v cos theta plus or minus j sin theta, where plus sign is used when it is used for representing a leading quantity, and minus sign is used when we have to represent a quantity which is lagging from the reference quantity or reference axis. Next we are going to study the third one or third form, that is known as the exponential form. Exponential form. Now in exponential form we will represent a phasor which is leading the reference axis by angle theta. We will represent it in the exponential form as small letter v is equal to magnitude into e raised to j theta plus j theta. Okay, this is actually derived from the trigonometric form itself, from the concept e raised to j theta plus or minus j theta is equal to, or I'll just show you plus 1. So e raised to j theta is actually cos theta plus j sin theta. So you can just see from the previous form only this exponential form is derived. Okay, so from this concept the exponential form is derived, instead of cos theta plus j sin theta, we have just represented using e raised to plus j theta. Now you can imagine what will be e raised to minus j theta now. Yeah, that will be equal to cos theta minus j sin theta. Okay. And this form is represented when the phasor is lagging the reference quantity by an angle theta. We will represent it using the expression small letter v is equal to, that means the phasor v is equal to magnitude, that is why I have written as capital letter V. You can see the magnitude is represented using capital letter V, e raised to minus j theta. Or we can generally say that we can express the phasor in exponential form as v is equal to v e raised to plus or minus j theta. Okay, I hope you understood the concept clearly. Now the last form of representation is the polar form. So what is polar form of representation? Let's study. In polar form, we will represent a phasor which is leading the reference axis by theta degree. We will represent the phasor as magnitude angle plus theta, where theta shows the angle by which it is leading the reference. Okay, from the reference it is leading by theta degree, which is represented like this. And you can just imagine what will be the case if it is lagging the reference quantity, that you can see here v is equal to capital letter V angle minus theta, which shows that this is the magnitude and this is the angle by which it is lagging the reference. Okay, it is lagging the reference. So generally we can say the expression as V is equal to capital letter V angle plus or minus theta. Okay, this shows the general expression. One more thing, here capital letter V shows the magnitude. In these both cases, capital letter V shows the magnitude of the phasor. Okay, what is the magnitude in the case of rectangular form? Magnitude is equal to root of x square plus y square. In trigonometric form, the magnitude is this one, capital letter V. Okay, in exponential and polar form also, the magnitude of the phasor is capital letter V. So I am going to just mark a dark red color over the important equations which you have to study. That is the general expressions for each case. The first one is the rectangular form of representation. X plus or minus jy. Then second case, that is trigonometric case, we can use or we can study this general expression. Well, okay, in the exponential form you can use this method, and for the polar form you can use this method for representation. Okay, next I am going to teach you what we can do for adding, multiplying, subtracting and dividing phasors. So write the heading as phasor addition and subtraction. First one we will go through what is phasor addition and what is phasor subtraction. So addition and subtraction. If we have to go for addition and subtraction, we have to use only one method, that is known as the rectangle form. So for addition and subtraction, rectangle form is used or rectangular form is used. Rectangular form is used for phasor addition and subtraction. I'll show you how we can do this. Okay, listen. If you are having two phasors, V1 is equal to, so I am going to use rectangle form. Why? Because we can use only rectangular form for addition. So I am representing the first phasor like this, x1 plus jy1. And I am having another phasor, that is V2, which is equal to x2 plus jy2. Then if I have to add them, that means if I have to find what is V1 plus V2, I have to do x1 plus x2 plus j into y1 plus y2. Okay, this is the answer for adding two phasors V1 and V2. And if we have to subtract them, we have to do as x1 minus x2 plus j into y1 minus y2. So this is how we have to add phasors or subtract phasors. So next we are going to study phasor multiplication and division. So phasor multiplication and division is possible with the help of polar form. Phasor multiplication and division. So let's represent two phasors to be multiplied and divided in polar form. So all of you write polar form is used. Polar form is used for phasor multiplication, and division. Okay, here you can see two phasors which we have selected is V1 is equal to capital V1 angle theta 1. Okay, and the second phasor is V2 is equal to V2 angle theta 2. We have used small letter, these representations are taken in polar form. Now we can just multiply them, which means V1 into V2, the phasors V1 into V2 will give you the result V1 into V2, that means the magnitudes are being multiplied, angle, add the angles, which means theta 1 plus theta 2. So your answer will look like this. Multiplying the magnitudes, angle, theta 1 plus theta 2. And if you have to divide them just like this, V1 divided by V2, then we have to divide the magnitudes, then take angle theta 1 minus theta 2. So this is how we have to multiply and divide two phasors. And one more thing I am going to give you is the rectangular form of representation of different types of impedances. So I'll just show you in very fast manner. I'll just teach you what is the rectangular form of representation of phasors, of impedance. Rectangular form of impedances. So what is impedance? Is the total opposition an AC circuit is opposing on the current is represented as impedance. So if there is only a resistor, we will represent, that means only a resistor is there, then the impedance is represented in the rectangular form as R plus J0. If you have only an inductor, if you are only having an inductor, the inductor will show an impedance, or it will offer an impedance, and this is represented by the method 0 plus J into XL, where XL is known as the inductive reactance, which is equal to L into omega, or we can also write it as 2 pi f into L, where 2 pi f is omega itself. Next one, we are going to study how to represent a capacitor. Then Z will be equal to 0 minus JXC, where XC is the capacitive capacitive reactance, which is equal to 1 by C omega. You can also write this one as 1 by 2 pi f into C, where 2 pi f is actually omega itself. Now, next we are going to combination of any two like this R and L. Okay. If we are having R and L, then we will write the impedance value as R plus JXL. Okay. R plus JXL. If we have R and capacitor together, then we will write the impedance as R minus JXC. Okay. And if we have a combination of these three, R, L and C, then our impedance value will look like R plus J into XL minus XC. So these are the ways of representing rectangular form of impedance. So by this we are closing today's video. Thank you everyone for listening. Stay tuned for the next video. Bye.